malware simulation to provide realistic cybersecurity training and realistic malware attack training to individuals? And if we can, how effective is this as a training method? And how do we measure that effectiveness? How can we understand what impact this is having on individuals and organizations to understand what sort of impact it's having, and if it is beneficial, how beneficial, or if it is not beneficial, in what ways? So the immediate question you might come from there is why? Why use malware for training purposes? And the key answers to that there on screen are really across industry and academic context. Malware training at current is very, very difficult. The type of training you might see within organizations might involve point and click, phishing simulations, whereby you might be informed of potentially risky behaviors, such as clicking links within emails, how that can potentially lead to an infection. And you might see some semi-interactive videos on what that looks like and how to prevent that type of behavior. That type of training is great, but it's often the case that that isn't representative of what happens in the real world when a malware attack and a cyber attack utilizing malware actually takes place. So you see a disconnect between what individuals are taught versus what happens during a cyber attack. And in that sort of gap between what the training is at the moment and the real world, that's when you can get the danger, and that's when you can get the disconnect and lack of engagement for individuals. And ultimately, if the training starts to diverge from what real world malware attacks look like and feel like and how they occur, it makes it more difficult to get individuals to understand how their behaviors could lead to malware infections and then how to prevent those type of behaviors. So in a similar vein, in wider cybersecurity, you might have heard of cyber ranges or pen testing training, whereby individuals might be given access to simulations where they can attack computer systems and capture flags with the purpose of sort of furthering their own education and training. And these tools are really fantastic, but a key limitation is they often don't cater towards malware attacks and malware-related training. And being able to set up your own dedicated lab environment to do this is, for a non-technical individual or an individual at the sort of mid to entry level of cybersecurity, can be very, very difficult to do. The technical knowledge required to set up a lab in such a way as to avoid getting malware to escape, for instance, can be quite difficult if you don't come from that technical context. And therefore, being able to design a lab in a way that protects you from accidental malware infections can act as almost a barrier to this form of training. So that's really the why. To sum that up, it's really the case that existing training often isn't as representative of what real-world cyber attacks look like. Trying to run something in your own dedicated lab can be very difficult if you, one, don't have access to a lab, or two, are trying to set up a lab yourself. The risk there can be quite high. And whilst there are existing tools that can allow you to, for instance, capture flags and learn pen testing, they're often geared towards wider cybersecurity rather than a focus on malware attack training. So on screen here, this is a quick one slide high level plan of what my PhD looked like. So I won't go through everything on the screen, but essentially distilled down onto a slide, it is to look into existing malware attacks, how they work, what types of malware are out there, and what types of technical defenses would commonly be used, and what the existing training mechanisms are in place. Survey individuals on if they've been involved with malware attacks, if they've been a victim of them, what they believe they would require in this hypothetical training platform, and essentially say, this tool doesn't exist, but if we were to build something, what would you look for? And then whilst we were doing that survey, it was to build the platform iteratively in the background, and then in an agile manner, integrate that feedback and those new non-functional and functional requirements as we went. And the idea there is just to speed up the cadence of delivery. After that point, it's then to analyze those survey results and align it with the platform design, and then get to testing the platform through a variety of testing methods you can see on screen there. So, from some of these surveys, understanding what individuals think about malware training at the current time and functional and non functional requirements, we saw that there is a huge interest in malware related training. You can see on screen there some of the statistics from the data. And there's an overwhelming interest in using malware training platforms. And there is also a equally in the opposite direction overwhelming trend whereby individuals believe that existing malware training through existing mechanisms might not be adequate. You can see that there with that 12, only 12% actually believe that the existing training for malware training is adequate, really. So we've got a situation whereby a majority of users would be interested in using some form of malware training platform. We've also got a situation whereby those same and similar types of users believe that existing training is inadequate. And then that leads us on to a situation whereby no platform currently exists exclusively for malware training to the best of the researchers' knowledge at the moment. It's also the case that this form of training using malware simulation does come with additional risks. Ultimately, if you're, watching a video of malware training and malware awareness or phishing simulations in your browser, and you're sort of doing interactive training in videos on that, that's going to carry significantly less risk than malware simulation, whereby you're running a contained cyber attack. It's also the case that whilst this form of training is seeing uptake through sort of pen testing, capture the flags, and similar sort of interactive simulations, we don't know what users would benefit from being included for malware training at the moment. And it's also the case that we don't actually know if various different types of malware would actually attack different types of people equally. And therefore, it makes it difficult to identify what training types would be beneficial to include in this type of platform. So, just a few challenges. So, on screen, this is just a brief timeline outlining some of the activities that I went through during my 3-year PhD. I won't spend too long on here. Happy to take any questions about this. And if anyone wants to drop me a line about sort of what the process looks like and development life cycle, more than happy to jump on that. But I've included it there just for sort of visibility. I think it's always good to have a timeline. But I won't spend too much time on that. I'll really just give it another 5-10 seconds and I'll jump over to the next slide. Great. So that takes us on to the development of the malware defense training platform. It's roughly 28K lines of code. That is, of course, including libraries and third-party dependencies. Not all of that is me. It's written with a combination of Laravel, Node.js, and quite a few other different frameworks and languages. And it uses a tooling on screen you can see there for virtual machine streaming, which we'll come onto in a minute. I'll go quite into the technical architecture on this talk, and I'll jump onto that later. So all of this will be demystified in 5 minutes or so. The tool, and one of the really interesting parts of this, is it operates entirely from a web browser for an end user. There's no downloading EXEs, MSIs, there's no config. You just go to a website, log in, and you're up and away. Another key element here is it can operate in cloud if you want to run this in AWS, or you can also run this on your own organizational environment or your own personal environment. Training packages can be imported and exported, which is another key element here. If you used other sort of cyber training providers, you might find that the training itself, you've got a selection, a catalog to speak, of different training packages that you can utilize. But you'll often find that that list of training is dictated by the platform owner. You don't really have a choice in terms of if you, as an organization, want to train on something else or develop your own training. So one of the key features of this platform is being able to share those training packages, which we come on to later in the talk. Also, administrators can make their own training, fire it into the platform, and everything that you see here, all of the code for it, will be open sourced on GitHub very shortly. So, diving straight into the architecture so we can get into this and how it works. This is fundamentally how the system works. I'll briefly run through this, and I'll briefly run through a little bit about how the training works and sort of the details here. So the key bits with this type of training is essentially to make malware training more realistic. It runs a contained malware sample within a virtual machine that users can interact with and experiment with as it operates. And the reason you're doing that is to create more realistic training that's representative of what a cyber attack looks like, and in a way, give a safe environment where individuals can experiment with something that they often wouldn't be able to experiment with in the real world, with the intention of giving them better idea of how things work, better ability to recognize risky behaviors, and a better ability to take a step back in the real world, recall what they've learned during the training, and mentally see how some of those risky behaviors can lead to malware infections. So this unified architecture model allows you to put everything on one physical machine. It's really simple to set up, but the scalability is quite limited because this will all run on a single machine. You've got a website, database, the actual web server itself, streaming components, a application programming interface API that controls the creation of virtual machines, and a storage system for the virtual machines itself. So this means all of the compute that runs the virtual machines and all of your website interaction data is stored in one machine. Really easy to set up, but very difficult to scale in this way. So one of the features of this type of platform and this technology that we've been researching is the ability to actually split this in half. This is slightly more complex to operate, but enables you to gain significant performance advantages, essentially separating out the back-end systems that run all of the virtual machines and the front-end systems that allow you to connect to the website and interact. This means you can have quite a cheap front end that doesn't take a lot to run. It's not too computationally intensive. And then you can have a very powerful back end that actually operates all of the virtual machines and storage systems for that. And it really enables you to pick and choose how you want to run this rather than it being imposed upon you. And I think that's sort of the key theme that runs through this is it's about giving greater flexibility to administrators to run platforms like this in the way they see fit, rather than relying on the conventional methods of training at the time. So what does this actually look like when you actually run something here? So say you're a user and you said, yes, I'd like to run a training simulation of a particular piece of malware. What actually happens? At a very, very high level, I'm just going to run through a couple of quick animations on what happens. So the virtual machines actually work through a virtual network interface and a virtual network DHCP server that assigns an IP address, creates a virtual network interface. A firewall is then applied for that individual virtual network interface, and then, providing the previous steps have succeeded, a virtual machine can then be launched and attached to that virtual interface. So I know that seems like quite a lot of steps to just run a single virtual machine, but all of this can be and is automated into a process that takes roughly 800 milliseconds from interface creation to actual launch. And the really advantageous thing here is this process is repeatable up to the limit of your hardware. So you can repeat interface, firewall, virtual machine for really any number of users up to the limit of your hardware. So as you can imagine, for training simulations and training purposes, this enables you to scale the solution far greater than you previously could, and far more than previous sort of conventional training, whereby you might be using sort of e-learning, which might not be as representative. Here you've got a way to massively scale up malware simulations for a large user base. So I've talked a little around the architecture, what malware training is, why do it, how it works, and then I appreciate we've got all the diagrams, but I always find that the architectural diagrams don't always show what it looks like for an end user. So more of the animations on screen at the minute. If you were looking at a monitor of a user running this type of tool, this is an example of what they would see. In the front end, a user would navigate to this website, and you will essentially be presented with, for lack of a better word, a one-way mirror into the infected virtual machine that you can see on screen here in your browser. Keyboard and mouse input go in, video input comes out. And as you're working through the training, you can complete questions on the right of the screen based upon the training activities. So contextualizing all of this against the diagrams that you've just seen, this is what actually happens. When you hit launch, the front-end system we talked about initiates a connection on your behalf to the back-end system. Once that is intercepted and handled, those previous steps of interface creation, firewall, and virtual machine execution are started. And then at that point, you're on to steps 3 and 3i, where the actual virtual machine is launched. The firewall prevents the malware samples from communicating externally, and then any sort of video traffic is then streamed back to the user through the streaming components and represented back to the user on that screen you saw earlier. So I touched upon earlier on this concept of training packages and how they can be exported and imported and created. And what I'm saying when I mean this is the virtual machine image itself, the thing that contains the malware and the operating system that users can interact with, a series of questions that can be built out as you'd wish for that type of training module, and then a brief description of it. And when you combine this together, you get what we've called a scenario. These can be exported, imported, created, and deleted through any instance of the scenario, provided you have the files for it. Pretty much drag and drop into the web interface, and it will import it for you. So to demonstrate what this looks like, I've created 2 scenarios which were used as part of the research process. Created a Windows WannaCry scenario that you can see on screen here, and one that I'll go on to in a minute. So before I go through the bullet points on there, I think it's really good just to take a quick look at the image on the right. What you can see here is a view of the desktop of one of the research participants that tested out the platform. And in this example, they're going through and looking to investigate a series of suspicious files on the desktop. It's just a quick GIF to explain what this looks like and how it works. And you can see here that a user has investigated a particular file and has accidentally launched it and actually triggered an infection. Because of the way the platform's built, we're able to intercept the video traffic that's being sent back and reconstitute that into an MP4 video that can be viewed back later. And then here, that's how we've got that GIF. But I think it's really useful just to see how quickly, for example, a WannaCry infection spreads from the click of the exe to the actual deployment of the malware itself. You can see there it's 2 to 3 seconds really. And I think it was definitely really powerful, as we'll come on to in the results when we see what users think about it. But as an example, in this scenario, you play the role of a systems administrator, and you've identified this particular anomalous system, and you perform various different tasks and malware analysis processes to investigate the suspicious files on the desktop. A bit like a game of high-stakes Minesweeper. Some of the files are legitimate, some of the files are actually modified versions of WannaCry that have been manipulated to look legitimate. And your task is to utilize a series of malware analysis tools and technologies and tactics to, at a very, very high level, identify which files are safe and which are infected. And the platform provides you a safe environment to do this, where you can experiment, learn, and investigate these files without the complexities of setting up your own lab environment or having to rely on, for example, an external tool to be able to do this. Alongside the actual task itself inside of the virtual machine image, questions, which we talked about before on that scenario slide, questions are devised by administrators as they've created the training package to support it. So for example, you might be asked to say, using this tool, can you identify particular behaviors, launch this particular tool, navigate to this column, what do you see? and you'll get a series of choices as to what to enter, and users fill them out as they go through the process, really identifying different features, functionalities, and elements of the malware. And ultimately, at the end of this, users can complete the scenario, receive a score, and compete with each other to see who can get greater scores. As well as the WannaCry scenario, we've also got a Linux rat infection, rat standing for remote administration tool. So your scenario here is a company server has been identified to be making strange connection requests very early in the morning, and you've been called in to provide instant response support and identify the source of those connections. So the questions rely on you sort of gradually running through different tools, technologies, programs on the server to try and identify strange behaviors and anomalous commands that might have been given. And what I'll do for a minute, if anyone's got a microphone on the call, on that image on the right, there's a couple of things in there that look a little strange, and I'm just wondering, does anyone want to have a go at calling out anything in there that they can see that looks a little strange?
Is it the IPv6 address that you got for TCP6?
Yeah, that's definitely abnormal. Absolutely. On the other sort of services running, do you notice anything? Anything sort of out of the ordinary? Any answers more than welcome. Don't feel like you need to put a hand up, more than feel free to sort of shout out. So I'll jump onto the next bit where I reveal it. So you can see here, you've got a strange process, PID 402 netcat in a listening state. And you can see there it's from a local address, port 4444. You can see it's in the listening state, and it's process ID 402. You can then see in the next state, a user notices this, and then actually kills that process, running kill 402. And you can see they run the same command again, netstat natp. And you can see there that this strange service running on port 4444 has actually subsequently been killed and doesn't show up. You can see there you've only got 3 connections there, 3 sort of services. But then after they run the command again, and you can see when they actually run it again, it seemingly reappears, even though it was killed beforehand. And it's an actual interaction of a participant actually trying to kill the malware, only to realize that it actually has rebooted itself. And what we've noticed as we're running through and people are trying this out is they're able to experiment with this. They're able to, it's not like a real world scenario where you have to worry about containment. You have to worry about immediately sort of jumping on this, containing it, and prioritizing reducing spread. Because it's in that isolated environment, you've got that freedom to fail. You've got that freedom to do things incorrectly. You've got that freedom to investigate things that you might not always have time to investigate in the real world. And things that are also really difficult to investigate in the real world. So having this has enabled quite a few users that we've seen to operate it, to really delve into how malware works at a technical level, as well as on the previous scenario, the Windows one, how to identify some behaviors that might lead to malware infection. So on that previous slide, we had a user that executed something that looked like a Word document. It was actually a doctored exe that had been manipulated to look like a Word document, had its manifest information changed, had some assembly information changed, and it had its icon changed. So even simple things like this for individuals within the industry, it can be really, really useful for individuals aspiring to get in and individuals wanting to learn malware analysis to see how these type of behaviors can occur and then how to protect against them, and really build up that sort of natural suspicion and skepticism towards behaviors that users might be taking, and then what the impact of those behaviors could be. So those were the training scenarios that were created for the research. As well as that, I mentioned quite early on in the talk that it's quite difficult to identify what types of malware attack different types of users. And we don't really know if malware attacks all users equally, or for example, if you're developing malware, if you develop it to target certain types of users more than others, if there's sort of a preference. So to that end, as part of my PhD, I've developed an affinity model you can see on screen here. The idea of this, in short, is to identify the different types of malware out there and to assign a weighting to various different types of users for those different types of malware. As you can see there, the large bullet point, smaller one in the middle of the third, where you've got, if you're a threat actor and, for example, you wanted to extort someone for money, you might choose a large organization, a large public or private, in the hopes that they have more resources and data of value than, for example, a user at home or a student. Idea being it enables you to get your objectives, which in this case, for something like ransomware, might be to get a large amount of money, for example, as sort of a threat actor. For example, in WannaCry, where intentionally or unintentionally, it spread quite prolifically within private and public sector organizations. So why am I talking about this in the context of malware training? On the right of the screen, you'll see there the process. I won't go through all of that, the literature review, the parameter matrices, the model calculation, and the incorporation into platform, which is the key bit here. So the output of this affinity model is a list of weighted values for different malware in terms of different types of users that it targets more than others. So the result of this is that the platform targets you in the same way a threat actor would. So when you create a profile on the platform, it will ask you what type of user you are. If, for example, you answer a student, it will load malware that it believes is more likely to target you as a student. If you select that you're a technical employee, it will select malware that it believes would have a greater success against a technical employee. And the idea here is to keep the training relevant to what you're doing and what you're most at risk by to reduce that risk as much as possible. So I've got a little video that will run on the right of the screen. And on the left, it's just a review of what that testing process looked like. I won't go through the whole of the video. It's just to give you a little demo as to what the front end looks like and what it looks like for a user actually completing this. So we had 16 participants, and they completed both of the previously mentioned scenarios, the Windows and Linux ones, resulting in 32 individual data points. We let those participants connect to an instance of this platform, gave them test accounts, they set their victim types, and were then able to crack on with the training. Because everything is kept in the training environment and within the tool itself, we're able to collect the score information, the time taken, and the actual video traffic that you can see of a user interacting with the scenario. We're able to capture all of that as part of the training platform. And then once completing this for the Windows WannaCry scenario, we then repeated the exact process you can see on screen with the Linux scenario. Once users completed that, it was then an interview of what they thought of the platform, what they thought of the tool, and what they thought of its impact on their ability to sort of recognize malware. So on screen, you can see an example of completing some of those questions, running through some of the instructions, and trying to identify a couple of indicators of compromise. In the interest of time, I will jump past this just so that we can run through some of those results. So overall high-level results are that 90% of those participants passed all scenarios, average of about 79, nearly 80% for the Windows WannaCry, and 76% for that Linux rat infection score there. We deemed that participants passed a scenario if they met over 50%. And you can see they're categorized by participant number from 1 to 16. Looking overall, we saw that public sector organizations scored the highest out of all victim types, and non-cyber students were at the greatest risk based upon their scores compared to other victim types there. We also saw that, not just looking at the scoring, but looking at timing data too, we saw that the average completion time for the Windows scenario was about, roughly half an hour, I thought at the time, but about 25 minutes really, and strangely shorter for the Linux rat infection, which we'll come on to shortly. So what we've done on the graph you can see on screen is compare the score difference after completing the first scenario to completing the Linux rat infection scenario. And you can see there that overall, most victim types actually scored higher on the Linux rat infection following completing the first scenario. You can see there for large organizations in the private sector, they found it considerably more difficult for that Linux rat infection scenario. Same with micro SMEs. But for most other victim types, it was a relatively significant increase in terms of scoring. Looking at it on time as well, we saw that not only did most victim types actually score better on the second round, they actually also completed it significantly faster. So after running through some of that data and after users had tried out the platform and were able to complete all of that, we went through a series of questions in a semi-structured interview. And what we've got on the right of the screen here is a variety of just unstructured words and adjectives that were used and extracted through natural language processing for each of the questions we asked. And you can see there that there are a few negative terms. I think we had stuck somewhere, but you can see, I'm struggling to find it, to be honest with you, but you can see really how there's definitely a statistically significant increase in terms of positive terms: interesting, engaging, realistic, advantageous, controlled, impactful, effective, hands-on, where users really think that this type of simulation and this type of training has really enhanced their ability to detect malware, and they believe it really compares favorably compared to other types of training in this area. You can see there some further questions on interfaces, interaction with the scenario, and recommendation systems. You can see there again, there are generally one or two negative terms and a significant majority of positive terms for pretty much all of the questions that we ran through. So, jumping all the way back to the high-level research questions and that sort of high-level problem statement slide, I originally asked, could we simulate malware attacks, and could we use this to provide more realistic malware training? And the answer to that is no tool exists that was able to do that in the way we wanted, with the ability to detect the different types of users and how likely they would be impacted by malware, with the ability to sort of export, import training in the way that we've described. So we set out to develop one. And from the results we have, we can say that simulating malware attacks is possible in this way, using this type of tooling with those feature sets and that functionality. We can also say, in terms of how effective is this as a training method, it looks like it's a very effective training method. All participants expressed positive sentiments. We had a few sort of mixed or negative sentiments, but those were drilling into the data. Those were actually from people that then expressed positive statements after all, which was really encouraging to see. If we zoom out from the interviews and then we look at the test data, the scoring data, we can see there that we really had a very high percentage of users actually being able to pass this. And really interestingly, users completed the second training scenario faster and scored higher compared to the first training scenario, which adds an additional bit of validity to those results in terms of what would this look like as a training method. And then there on the assess the effectiveness of the simulated training, we've used a variety of different evaluation methods. We've looked at scoring, we've looked at timing, and we've also looked at interviews with the individuals that have tested this out, really with the idea of understanding, do the scores match what the interviews are saying? How does this stack up over time, comparing over a couple of different scenarios and seeing what users think of it and how users are able to develop? And generally, we can see that this type of training has had a really positive impact, and users are really excited about using this type of interactive training. So, with that being said, I'd just like to say a massive thank you to Dr. Abu Alam, Dr. Kublai Ali Mirza for supervising me, the University of Gloucestershire for supporting this research, all of the participants who volunteered to try out an experimental malware training platform. It was quite hard to collect data for this, so massive thank you to those that were willing to try this out. And a general thank you to the open source community for providing frameworks, libraries, tooling, and scaffolding that enabled this sort of technology to be developed. So massive thank you to all of those. That being said, now that I've gone through all of that, this isn't a silver bullet, this isn't a catch-all, but it enables us to take a weapon that attackers are using, i.e. malware, and actually try and use those weapons to learn about how to prevent future attacks. Ultimately, they're going to continue throwing malware at us, so we may as well try and use it to train individuals on how to identify, respond, and prevent cyber attacks. And it also doesn't replace existing training. It definitely does have a skew towards technical individuals, benefiting non-technical individuals too, but really goes hand in hand with existing training methods as a really nice supplemental form of training to have. And then I think that is everything, and I can just jump onto any questions that anyone might have.
Thank you very much, Alex, for this insightful talk. Yeah, if you want to switch back to your other device, that's fine. Otherwise, we'll see if there is any questions. And I think Chris has a question. So yeah, if you can unmute yourself, Chris, and ask the question, please.
Yeah, I can understand the difficulties with some of the environment. I'm interested how you found the process of choosing the right kind of front end to interact with it with Apache Guacamole. Was that your first choice, or did you kind of fall on that and realize how robust it is in the end? Because I had a similar sort of journey picking a front end for a completely different task, actually. So I was curious how it was you decided to choose Guacamole to use.
Yeah, sure. And it's a really, really good question. And I know exactly what you're hinting at there. There are quite a few different technologies that you can use. There's a lot of really good free VNC viewers and open source VNC viewers. One of the really good things about Apache Guacamole here is I want to say it's protocol agnostic in that later down the line, you can choose between RDP connections, VNC connections, and SSH connections. And it can translate using Guac between any of those into the native Guacamole protocol. So the benefit there is we've actually got an option in the scenario. I haven't got a picture of it, but as an administrator, when you're completing it, you can specify the type of protocol you want to connect to the VM over. So for example, if you want to do a desktop, you can click VNC. That will then be added to the database entry for that specific scenario. And that will allow you, when it comes to actually executing connections, to connect over VNC. Well, connect over Guacamole, which in turn connects over VNC and gives you a nice graphical environment. But if you've got a Linux command line and you just want SSH, it enables you to pick something like that. So I suppose that is the key reason. It's the flexibility, and it adds to the realism because it means that what you actually see on the screen will likely reflect what would happen in real life. If you have a server with a graphical environment, you can simulate that through this training method. But equally, if you want to go for more technical training and simulate, plugging a KVM into a server room and firefighting something in real time, we can equally do that just with an SSH terminal.
That's cool. Good to hear. Thanks for the answer.
Thank you very much, Chris and Alex. Is there anyone have any questions? I can see Abdul Rahman posted on the chat. So will there be any continuation to this course? I think I know the answer. So yeah, this is not a course. This is as part of our British Computer Society's monthly talks. So every month we have a different speaker, and it will continue until May. But if you want to connect with Alex, by all means, you can. As Alex said in his talk, that if you want to have any questions or anything, you can connect with Alex. Yeah, okay. Thank you, Abdurrahman. Is there anyone else have any questions? Yeah, I think Ashok is typing, but yeah. Yeah, I have a question, Alex. Just really curious about, what's your future plan with this platform, because it took a lot of time to build it, and other than making it open source, do you have any other plan with this platform to extend it, or any other plan?
Yeah, I think there are a few things that I would love to do with this. Now that I've seen it built and I'm looking back at the process and the journey, there are definitely a few things that I think would be really interesting to develop. I think a few of those things would be, for example, we've got the concept of scenarios at the minute. There's a one-to-one mapping, so one user can operate one scenario at a time. What would be really interesting is to almost create a scenario group as a sort of logical representation, whereby a scenario group could contain multiple scenarios, and that could be mapped one-to-one with the user. Idea there being enhancing realism and providing a more representative of what cyber attacks could look like. So, for example, a machine has been compromised across the network,